Testing, testing. Okay, I'm on. Ooh, sorry about that. My audio seems to be a little flaky this morning. I don't know what's going on. Okay, well, let's try again. Hello. I already said this, but didn't go out. Hello and welcome to my stream. Apologies. Okay, so we've been working this week on the crafting interpreters, and we got up to this, which is the keyword. This that's used inside classes, and I think we have. I pushed this actually yesterday after the stream, so we should be we're up to date now. Yeah, you don't see the push here. I did it in a different window. Git log. So we finished up getters and setters for class objects, and we did methods on classes, and then I did some toString cleanup. And actually, I went and learned a little bit more about toString, and I think I didn't know enough about toString yesterday. Rust, format, display, toString. I think if you implement display, you get toString for free. Yeah, you should not implement toString manually. toString trait is already implemented for all types which implement format display. So that I should clean up before I do anything else, because I do have some toStrings in here. So I should get rid of all those and replace those with display before I go any further. So let's take care of that mess first. toString. toString I can't type today. All right, so the way you do display, and I think I have an example here in object, is you just use this. So you can just grab that and put it here, and instead of object, this is going to be a locks function. And for the function, let's go to that. What do we have? Actually, let's see, quote new. Okay, I just wanted to copy that to the others. So what can we display? We actually have the name here, so we can print it all out. We can say write f function name like that. And we can actually we know the parameters are, and we have all the tokens, so we can actually just. Why don't we do that? That would be a better. Better way to do it, right? We can just create a quick little vector here. Let mod. It's a params rc vec token. Okay, so can we do it as in a functional way? Let params. Oh, no, I guess we could just build it up, right? Let mod param list equals string from. No. Right. And then we can say for p in self params, and then we have the token, and we just we want to basically do a join, because what I want it to look like is function foo abc. That's what I want the output to look like, because we have the parameter names in there. Locks doesn't have parameter types, so I don't think we have to worry about that, but we can put the parameter names in, which is nice. And which means we want to join them with commas and a space. So let's see what we can do here. Rust string join. What's the equivalent of the join operator? Okay, so we could just take a vec and do a join, and we're done. Okay, so we don't have to do all that. We can just say param list is equal to, and we have the vec, self params is the vec, and we just say join. Oh, it's a list of tokens. So we need to convert that to a list of strings. So we say map p into p dot, and the token is just as string, right? And then join, like that. Will that work? Oops, I didn't finish this line here. It doesn't seem to mind that, so we can just put the name, the function name here, and then open paren, params, close paren, or param list. It doesn't have to be mutable anymore. So param list, and then this is just self dot name dot as string. Right? Nope, it doesn't like that. Oh, we don't have format display. Use standard format display. Right? Ooh, doesn't like that either. What did I do in object then? Oh, just standard format. Okay. And this is, we can't do a map on RCVec token. So is there a suggestion about what we can use instead of that? We have to call deref or something? Rust map RCVec. Cloning from vec or ref counted. No. Iterating, or there we go. Whoa, that's a big font. Can I just call iter? If I don't have integers. Okay, so maybe I can't do this. That's annoying. Okay, we got past that. Method not found in collect as vec of string dot join. Yeah, okay. So yeah, so what's all this business about? How do we fix it? I guess I didn't really read it. What's the fundamental problem here? Problem is that only has shared ownership of the vec and therefore doesn't offer an API that will return you a vec32 value. You can only get back reference. Okay, that's fine. I don't care about getting references because I just get what I need. Okay, so let's see if this works. Format display for locks function, and then in object function we should be able to call, I can't use f, I can just call it func though. And I can just say this func to string like that maybe. This is getting distracting over here. Okay. Sorry, I'm just trying to set up my alternate screen so that I can see what I need to see. Okay. So does this work? This works. Can we print it out? How do we test that? Cargo run. I can just create a function, fun foo, and then print it this way. Oh, this just says func callable. Oh, because it's not a locks function. What's the difference between a callable and a locks function? Oh, yeah, it's callable. Oh, because I'm calling func to string, which is a callable, not a locks function. Do we use locks function anywhere then? We do for methods in our class, right? Which I can't print out. Locks function. Yeah, that's the class thing. This is visit function statement. Yeah, and it creates a callable of a okay. Inside the callable there's func though. So maybe that's what we need to change, is inside callable is to call the func's display. right? So if I say implement display for callable, what I'm doing right now is just saying write callable, but I can actually say, let's call the funcs callable, which we don't know if it's possible because it's a loss call. Dang it. That's right. That was the problem we had before. So I need to clean that up. But meanwhile, okay, let's undo all of those changes. We got rid of the toString that's in locks function. Let's get rid of the toString that's in locks class. And instead, we're going to do the same thing we did with locks function and just have use standard format like that. Don't need two of those copies. I don't know why I did that. And then how do we want to print this? We also have name and methods. Okay, so we can print out those, right? And for methods, we can just print out the strings. How do we want to indicate that they're methods inside the class? So we'd want to say class foo open brace, and then we can say method name like this. Like that. Or we could leave the braces off, although it'd be nice to be able to print the parameters that the methods take. I guess we can just start off like this. This would be the easiest thing to start with. So let methods equal self methods keys, right? How do you get the keys of Rust hash map vec of keys? And it's how you collect the values. I don't want the values, I want the keys. Into keys. That's it, into keys. Into keys, select, join, comma, like that. And then so we can say write bang F, class, name. I can't say self.name here, not yet. Someday. And then an open brace, and then a list of the methods, and then a closing brace, and then a closing bracket like that. So then self-name, methods. Oh, that one I can put in. Like that. Does that check? Nope. Oh, for locks function, for locks class. I forgot the points on there. It doesn't look like that because it can't include the type. Vec string. And it doesn't like that because there's a move. Can I say iter keys? No, there's just iter. Oh, just keys. I can just say keys. I don't need to say into keys. And I can't do a collect on that. Vec string can't be built from an iterator of item of string references. Can you build a vector of string references? And a method can't be called on a vector of string due to unsatisfied trait bounds. Okay. Rust, why you gotta be like this? All I want to do is... Okay. What I can do is copy, right? Or cloned. Like that. There we go. So I have to clone them into this vec and then join them and then print them. That's kind of frustrating, but I guess that's what you got to do. You can't reach directly into the hash map, is what they're saying. So let's see if this works. Cargo run, and I'll create a class with a function called bar, which takes A and B, and prints A plus B, and that closes the function, and that closes the class. And let's print it out, and what do we see? Class locks, class name, oh, this is the debug output, not the print output. Ah, I forgot. Is there a... Oh, right. Let's see if I can just say print foo. Oh, class foobar. Oh, and the reason this happened is that I actually have that in object as well. So what this should just be doing is printing out the class's representation of itself, right? So let's try again. Let's put this in here. Print foo. Yeah, class foo with a method bar. And if I had multiple methods, oh, I wonder if I can redeclare things like that as and clicks. Yeah, so they're all in there in no particular order because it's a hash map. Okay, so that's that one, and the last one is locks instance. So we're gonna put this here. We're gonna say change this function to instance, and then we're gonna say instance of class, and it's gonna show the fields on the class, I guess. Right? I think that's the best way to do it. So we can just say right bang f instance of this, of the class name with the fields, and the fields map to an object, so we should be able to come up with a full list of everything, right, just by looping over each field in that hash map, just like we did for the other one. So the first thing is going to be this self class toString, and that's actually going to print out class with all the methods, right? And then in the instances are going to be, or the fields are going to be on their own little hash map. So we're going to say just very similar to what we did here. Let fields equal self fields borrow, because it's inside a ref cell. Oh wait, we can do the name value pairs, right? Because we have the object that they are, so we can just print those out. So we're going to borrow that, and now we have the hash map, and so we want to grab get key value. Or iter, I guess we can just iter over it, and we get the key value. Yeah, so we can say that fields equal let mut fields vec new for kv in self field borrow iter. I might have to ampersand that to avoid any issues, and then just say fields dot push format bang k equals v. And then we can print that out using join since those are strings. So fields.join. Oh, how do you want to separate the fields? I guess with a comma too. It might get ambiguous. Right? And then we can get rid of this guy. Let's see what blows up. All right, standard format. That builds. So now we should be able to say cargo run. Class foo. Var f equals foo. Printf. Instance of class foo with no methods and there's no fields. So now I can say f dot 1 equals 2. And printf. Oops, printf semicolon. And now it says 1 equals 2. And I can say f dot 3 equals 4. Printf. Printf. 3 equals 4. Okay. So that's pretty nice. Git status. Git and source. Git commit. Clean up toString. Use display. Okay. So that's done. Let's dive into this. Section 12.6. We can define both behavior and state on objects, but they aren't tied together yet. Inside a method, we have no way to access the fields of the current object, the instance that the method was called on, nor can we call other methods on that same object. To get at that instance, it needs a name. Smalltalk, Ruby, and Swift use self, similarly C++, Java, and others use this. Let's insert Rust in there for self. But that's by convention, right? Python uses self by convention, but you can technically call it whatever you like. Can you do that in Rust? Oh no, I think it has to be called self in Rust. I, in quotes, would have been a great choice, but using lowercase I for loop variables predates OOP and goes all the way back to Fortran. We are victims of the incidental choices of our forebears. That's true. For locks, since we generally queue to Java-ish style, we'll go with this. Inside a method body, this expression evaluates to the instance that the method was called on, or more specifically, since methods are accessed and then invoked as two steps, it will refer to the object that the method was accessed from. That makes our job harder. Peep at this. So class egotist speak, print this, var method equals egotist speak, and then we call method. On the second to last line, we grab a reference to the speak method off an instance of the class. That returns a function, and that function needs to remember the instance it was pulled off of, so that later on the last line it can still find it when the function is called. We need to take this at the point that the method is accessed and attach it to the function somehow, so it stays around as long as we need it to. A way to store extra data that hangs around a function, eh? That sounds like an awful lot like a closure, doesn't it? We defined this as a sort of hidden variable in an environment that surrounds the function returned when looking up the method. So if we define this as a sort of hidden variable, then uses of this in the body will be able to find it later. Lock's function already has the ability to hold on to a surrounding environment. Right, because we create a new environment here, and we do have this closure business going on. So we have the machinery we need. Let's walk through an example to see how it works. So let's actually copy paste this so we have it for testing. There it is. This dot flavor, cake is adjective. Our adjective is delicious. So this is just showing that we can get local variables and we can get things that hang off of the current class. Okay. When we first evaluate the class definition, we create a locks function for taste. Its closure is the environment surrounding the class, in this case the global one. So the locks function we store in the class's method map looks like so. So we have the taste, which has the closure of cake and the cake instance. When we evaluate cake.taste get expression, we create a new environment that binds this to the object the method is accessed from. Here it's cake. Then we make a new locks function with the same code as the original one, but using a new environment as its closure. Interesting. So we're creating a brand new function when we call something that has a this. This is the locks function that gets returned when evaluating the get expression for the method name. So every time we call a function, we're creating a new function to bind the this value. The parent of the body environment is the environment we created earlier to bind this to the current object. Thus, any use of this inside the body successfully resolves to that instance. We're using our environment code for implementing this also takes care of interesting cases where methods and functions interact, like this. Get callback. Oh, so this is creating a function locally and returning a reference to that. Well, I don't know if it's a reference. It's a something. It's a thing to that function. And when we call thing.getCallback, so we create an instance of the variable here, then we call getCallback, which creates this function and returns a pointer to it, and then we can call it. That's going to be crazy. In, say, JavaScript, it's common to return a callback from inside a method. That callback may want to hang on to and retain access to the original object, the this value that the method was associated with. Our existing support for closures and environment change should do all this correctly. All right, so let's create this also. Thing locks. Boom. So this should all work. Oh, except we're not going to be able to see it. Oh, we'll print this. So we should say instance of. I mean, it should work. I guess. It'd be nice if there was a little something there. Okay. Let's code it up. The first step is adding new syntax for this. So let's go into our mod, and we're going to go right after set here and put this. And it's going to contain just a keyword. Okay, that's easy enough. Parsing is simple since it's a single token, which our lexer already recognizes as a reserved word. Okay, so let's go to the parser. In primary. Here's primary. Where do they have it? Just before identifier. So that's right down here. Return. It's going to be okay. Expr this. RC new. This expr. And it's just keyword, right? It's going to be self.previous. Where else do I use previous here? And yeah, okay, so I do call dupe on it. Okay, so that's the parser. You can start to see how this works like a variable when we get to the resolver. So when we get in the resolver, set expr. Okay, so fn visit. Oh, we can just copy, paste, change set to this. So it changes to this, and all we're going to do is say call resolve local. Where else do we call resolve local? I want to see how to do it. Okay, it does not take a question mark. Local wrapper, which is this guy, and then expr keyword, and return okay. All right, that's straightforward. We resolve it exactly like any other local variable using this as the name for the variable. Of course, that's not going to work right now because this isn't declared in any scope. Let's fix that over in visit class statement. Okay, so that's over here. In visit class statement, we haven't declared visit, or sorry, we haven't declared this yet. So that's what we need to do here. So right after begin scope, oh no, we have to add begin scope. So right after define, we're going to say begin a new scope. Okay. And then self scopes borrow. And then saying peak, which is the same way of doing a last. Right? Unwrap. You do that same thing. And then borrow, mute, insert this to string. I'm just following this here. It's got to be a string, and then true for Boolean. Wow. And then we need an end scope. Okay, that's just before the self end scope. Okay. So this is the peak, and that's the put. Right, the way we have to do the peak is it's a ref cell of vector of ref cells of hash maps. So we have to borrow to get to the vec. We have to grab the last one and unwrap it to get to the peak. Right, and then we need to do borrow mute on that hash map that's inside that vec to insert this true. Okay, I'm going to see if it checks. The interpreter is going to fail because we don't have visit in there. But if that's our only error, then yeah, then we're good. I think we're good with this. It's a little complicated, but it gets the job done. Before we step in and start resolving the method bodies, we push a new scope and define this in it as if it were a variable. Then when we're done, we discard the surrounding scope. There's the end scope. Okay, now whenever this expression is encountered, at least inside a method, it will resolve to a local variable defined in an implicit scope just outside of the block for the method body. The resolver has a new scope for this, so the interpreter needs to create a corresponding environment for it. Remember, we always have to keep the resolver's scope chains and the interpreter's linked environments in sync with each other. At runtime, we create the environment after we find the method on the instance. We replace the previous line of code that simply returned the method's locks function with this. We're calling bind now. Okay. So that was right over here. Oh, no, this is in fn get. There is no fn get in the interpreter. Oh, in locks instance. Sorry, I missed something here. I was thinking that we have to go to the interpreter, but no, we have to go to the instance right now. Here's get. We call find method. If method is not null, then we're in here. And what we do is call method.bind self. Oh, return. Return method.bind self. And self is a reference to an instance. And we have to write bind now. Okay, so let's write bind. So what is this going to look like here? Pub fun bind self. Because we don't need to. Oh, no, it's not here. It's in locks function, right? It's going to complain that bind doesn't exist. Oh, right, in locks function. Oh, we have a problem. We need to get the, that's an object, right, that we get out of here, and we need to destructure it into the function itself. If let object func. Oh, let me just double check that that's what I think it is. Let equals method. I think that object, it's type locks. It's object found. Oh, darn. Tell me the type inside. Object. What we're looking for is this, right? Oh, so it has to be callable. Should I change this to a locks function? Because we need to be able to bind. because all callable has is that locks callable business going on. Maybe that, maybe we shouldn't be doing it this way. Maybe we should be doing a locks function here. And since locks function implements locks callable, the locks callable trait. All right. So let me quit out of this. Get diff. How much did we change? We didn't change that much, right? We have this. We have the bind thing. Oh, we did all this work here. Well, I mean, we can always redo it. The problem is, I'm thinking, well, I'll do a stash and then unstash it, but I don't know what I'm going to break if I do that. Because I want to, okay, get stash. Okay, so, and I have to read up how to unstash. Git restore stash. Git stash apply. I guess. Git stash apply. Yeah, okay. Simple enough. All right, so what I want to do, I want to start with by modifying this. So we have RC locks function and see how much of that breaks our code. All right, let's try this and see. Oh, not found in the scope. Because there was a reason we went through the whole callable business. So this is a class statement. We're going to say locks function, RC new locks function. And what does the locks function take for new? The declaration and the closure. Oh, yeah, so we actually have it right here. So that gets rid of that, right? Oh, and I missed a closing brace somewhere along the line. What did I mess up? Oh, that is not needed anymore. So that matches that, and that matches that, okay? And then we do the same thing here. And now we no longer need to do that. Right, and then here, same thing. Ooh, oh, we don't have that ability, right? I can't just do this because native clock is not a locks function. So this is what's going to break. Yeah, so this won't work. What's the way around this issue? Right, that was the reason I was doing it with the callable, because I wanted to be able to put any callable in the way, including this native clock business. If this is, let's come back to this. Oh, locks function doesn't implement debug. Right, and maybe we had a problem with that too. Because it has to implement has to implement all these guys, right? And I don't think it can. I think we tried that yesterday and it failed. Yeah, because statement doesn't implement debug. I can implement it manually. Let's see if it'll implement these other two things though. Clone is not implemented for token, huh? Okay, well, I mean, I can implement these manually, right? So we just need debug, clone, and partial equal. Where else do I have debug implemented? I don't have it anywhere. I thought I had it in object. Oh, I had display. But it's the same thing. Okay, so impl format debug, the locks function. I think it's just format debug, right? Missing format in implementation, right? And then impl clone for locks function. I mean, it's simple enough. All I have to do is duplicate the token and then clone all the RCs. That's easy. Impl partial for locks function. And you can just compare the RCs on those guys. All right, so this is just function format self. F is formatter, right? And then it's a result of format result, something like that. Right, bang, F. Can I just call the toString method on it? Because we already implemented that. Oh, center format error. Yeah, and then clone is easy, right? Fn clone, oops, Fn clone, self, name, self, token dupe, params, RC clone, self params, body clone, self body, and closure, RC clone, self closure. Don't need a J over there. Okay, and then partial equal, so Fn eq, self, other is self, and returns a bool. Do functions ever have to equal each other? I guess so. If you're looking them up. So how do we check to see if the token's the same? I forgot what token looks like. Oh, we can't do partial equal on that, but we can check, at least check to see if the token type and the string are the same, right? Because those, token type implements equality, I think. So it's self dot so we can get the token type right there. So self dot name dot token type equals self other name token type, and RC pointer EQ self dot params with other params, and we do the same for body and for closure. Right? Anything else we need to do? Unknown field. Oh, this is name. Okay, 2 warnings. Oh, right, we're not using native functions yet. Okay. That I can live with. So we now have locks functions as directly in here. So now we should be able to use that information to extract the methods. So we can go into our instance. Oh, first let's save this. Oops, didn't need that. Git diff. All we did was rework or lift out function to a first class type, I guess. It's not going through that callable business anymore. In fact, maybe we're not even using callable anymore. Implement locks callable for locks function. The only thing that's bugging me now is the fact that we don't have native functions, and that might have to be a separate thing, and I'll do that. Epic Blog says, how goes the interpreter crafting? Any interesting bumps in the road lately, or has it been smooth sailing? There's nothing smooth about the sailing on this in this book. If I was doing it in Java, obviously it would go really smooth, right? Common metaphors regarding progress involved means of transportation. Yeah, that's to be expected, right? Yeah, so what I'm trying to struggle with now is the fact that we have Java has the concept of being able to just throw around objects willy-nilly, and I'm struggling learning how the traits can handle that, because right now we have this locks function as a function, and each one of these implements locks callable, but I can't just extract it as a locks callable. I tried that a couple of streams ago. In our interpreter, visit call expr, I should just be able to extract function or class or instance. We don't have that yet. And get a locks callable trait object, but I wasn't able to do that, or I don't know the right syntax for that. Right, I should be able to say let call func equals match on call e. It's an object func. Which are f as locks callable. Locks callable is a trait. Right, and then so this actually should be some like that. Oops, what did I do? Like that, and then the same thing for class. And the same thing for instance, and then everything else becomes a none, and then we can say if call func is none error, else call the call func through the sum. Right? I should be able to do that, but I don't think this is, you can't as into a trait. I wonder if you can force it this way. Can you force it this way? Locks callable option. Let me try this. And then object class C, sub C. Object instance, right? Because instance implements it, right? Oh no, it doesn't. So the only things we care about are the object and the classes right now, or the functions and the classes. Because this implements locks callable. There we go, right there. using as that way seems a little sketchy. Yeah, I don't think it even compiles. I'm gonna see if this even. Oh, well, it got this far, but you know, the way Rust works is everything takes 17 passes, and so you think you're getting close to getting something working, and then bam, the borrow checker stabs you in the back, right? So does this work? No, see, didn't. Okay, maybe that works. Nope. Doesn't have its size known at compile time. Right, so that was the issue we were seeing yesterday. Expected trait object din locks callable. Found struct. Oh, I can deref it. No, even deref doesn't. Expected option din callable found option. Oh yeah. So found a locks function, right? So the locks function implements locks callable. Yeah, so the deref, all it did was, I can try that, deref clone. That's not gonna do it, right? Yeah, see, so this locks function, : locks function should cast into a din lock callable locks callable, because locks function implements the locks callable trait, and yet Rust won't let you do that. And we don't know what the size of this thing is, which is fair. I could always make it an RC. Right, so that gets rid of that issue, but I don't know. Oh, okay. Wait a minute. Wait a minute. Is this it? Is this it? And then can I say call? I can just let's try this. If let some call func equals call func. Is there a way I could do that in one statement instead of having to destructure it? Something else. Why did it go there? There. Else. We have an error, runtime error. This thing here. Right? Uh-oh. Is this going to work? That would be crazy. If you just want to work around the size bound, use box instead of RC. Well, this is already an RC in here, so that's why I went with that. But yeah, you're right. The box would have been the way to go. Pum. So we can say if arguments then is not equal to call func already. Right? Grab that, splop it in there, and then otherwise call func. Call? Will this work? If this works, I will be very happy. Self arguments. And we just return that. One error. Oh, function error. This should be call func. I guess I could have called it function. No way. Why did we suddenly stop being able to instantiate? Variant is never constructed. We're never calling instance. How are we not calling instance? Oh, because I do class instantiate. Oh, right. So for classes, that's right. I had to work around the problem, but I think we solved the problem. So now instantiate becomes the call. So locks class. Right, here's instantiate. Oh, right, I had to do the instantiation because I have to pass in a class reference. Dang it, so close. But at least we're able to do this part of it. All right, so how do we handle the instantiation then? So maybe it should be in two separate steps. Is we should return Right, I want to be able to handle this.
What is this place?
Because at some point we're going to have to handle the classes being able to pass in arguments. Oh, well, I mean, that would still could be in the instantiation. All right. All right. I think I'm getting to where I need to be. I just need to figure out. So what we were trying to do, the reason I'm going on this tangent is because I need to be able to bind. I need to be able to call bind on the locks function, and I wasn't able to do that using the setup we had last time because all we had was a callable. And now we actually have a locks function here that we'd actually be able to call the bind on in our visit call expression. I mean, in our locks function. In locks instance, can call bind on the locks function that's inside the object that we got. That's where we were going with this.
What is this place?
All right, so this is going to be a temporary thing here that I want to come back to. Meanwhile, this should still work, right? Oh, I don't know how to pronounce your name, but thank you for the follow. Let's try Patakapis69. Nice. Epic says, sorry for sidetracking you from what you're actually doing, but it seems kind of interesting. Yeah, you know, you're not sidetracking me at all, but don't worry about it. This is all good stuff. So, oh right, where I was going with this, I forgot. Yeah, where I was going with this was I was trying to get native functions to work by putting using this kind of a scheme, just to be able to call. Right, and then instantiation doesn't work with the call way of doing things because we don't have access to the class. And I want to be able to put the classes, a reference to the class in the instantiated object. Because the instantiated object needs to be able to go back to the class to find the methods. And if you can't find the methods in the class in your instantiated object, then what's the point of being a class? So, is there a way maybe we can extend the call interface to pass in not just arguments but also the reference to the class? I mean, maybe that's the easiest way to do it. Would have to know that though. What's class? So class is, oh yeah, it has to be the actual class. Dang, I don't think there's a I don't think there's a good way to do it. All right, I'm going to ignore native functions for now, and well, it'll be something we come back to later because I do want to finish this. And I will leave that compilation warning in there as a reminder to me. So this is basically git add source, git refactor, git commit -m refactor locks function. Need to fix native function calls. And that'll be something. So now git -apply. Oh, good, that all worked. Okay, so now we're back to this, where we're going to be able to call bind on the function that we got, right? Because we're going to get back an object which is going to contain a locks function. That was the whole purpose of that rigmarole, right? We're going to say if let object func equals method, then the function itself, we're going to return func, I guess, okay, func.bind self. Otherwise, we're going to panic because we shouldn't be doing that. Try to bind this to a non-function. I guess we can just put method in here. Like that. Oh, didn't like that. Oh, right, because we haven't done this part of the code yet, but what's wrong with this? Oh, we don't have bind yet. Right, so okay, let's write bind now on locks function. Here's locks function. Pub fun bind. Okay, so here we go. And it's just going to take an instance. So self and instance, which is going to be a locks instance, I guess, and it's going to return a new locks function. So it's going to be self. Basically, this, right? We're going to clone ourselves, which we already have. We can say let mut me equals self.clone, because we have that. And then what we're going to do is we're going to create a new environment. Oh no, we're going to just new it right here. Okay, let me follow the code. Let environ equals environment new with enclosing. I'm just following this line down here. RC clone self closure. So we do the same exact thing. Then we say, oh, it has to be mutable. Environment define. This, probably toString, and then the instance. Oh, which has to be an object, because the way you define things, it has to be an object. Unfortunately. Okay, that's fine. And then you're going to return a new locks function. Like this, with the declaration. So, oh, RC. Oh, yeah, our declaration is split apart like this. So we're going to return a locks function like this then. I guess self. Sure. Name is going to be self. Name dot. Params is going to be RC clone. Self params. The body is going to be the same. It's just going to be. So all I'm doing is cloning. Oops, I misspelled clone. I'm just cloning the reference. I'm not cloning the whole function. And then the enclosure is going to be this environment that we just created. RC new environment. Like that. Right? And we've got 6 issues here to solve. Expected stir found string. Oh, really? Okay, so I didn't need to Okay. I didn't like that with the semicolon there. Expected enum object found. Oh, reference to an object. Instance clone. That's annoying. Okay. I'm not going to worry about the visit this expr. Oh, this has to be a ref cell from construct environment. Really? Down to 3 warnings. Oh, right. We're not passing in self. We're passing in our object. Ooh, which we don't have. Yeah, so this is passing in the object that this is, which is a locks instance. So how do we get that into our environment? We'd have to say object instance self, right? But how long is that going to live? Is that going to give us issues? RC new. Wow, so this might end up being really bad because we're creating a brand new RC for it. Oh, it doesn't like that. Oh yeah, expected lot. So then we have to clone it. That's wonderful. What is it expecting here? Expecting this. Wow. Down to 2. Expected. Why is this like this? Expected object found struct locks function. Oh, because bind is returning a locks function, not an object of a locks function. So bind should be returning an object. So we can say object func. Still 2. Mismatched types. Oh, it's got to be RC'd. Okay. And we're down to 1. Okay. And it's just this expression. Okay, so I did enough work. Oh, it's platypus, but in Czech. Oh, thank you. So, Ptakopsk. Oh, okay. I don't know how to pronounce Romanized Czech words, I'm afraid. I assume the 69 is also a reference to a Czech word. Sorry, that was not okay. That wasn't funny. There isn't much to it. We create a new environment nestled inside the method's original closure, sort of a closure within a closure. When the method is called, that will become the parent of the method's body's environment. We declare this as a variable in that environment, bind it to the given instance, the instance that the method is being accessed from, et voila! The return function, locks function, now carries around its own little persistent world where this is bound to the object. The remaining task is interpreting these expressions, similar to the resolver. It's the same as interpreting the variable expression. So it's fairly straightforward. Visit this expr. Let's just put it here. And this becomes this over here. And all we're going to say is the same as the visit variable, right? Which is going to be just this line. Except it's keyword instead of name. Right? And I don't know why this comment is here. That's probably from from the before times. And we do need the wrapper. Okay, so that builds, and the only warnings right now are the native function warnings. So let's see if this works. So cargo run. It says go ahead and give it a try using the cake example. Don't die, don't die. Ooh, already mutably borrowed. Okay, yeah, so here we go. Do you have any unsafe code, or have you been able to avoid it so far? I have no unsafe code. I don't know. I mean, I've watched some videos on unsafe work. John Ginsit. I don't know how to say his name. He says how to say his name, and I keep forgetting how to say his name. Has a good video series on unsafe and safety, and how you can basically, whenever you write write code in an unsafe block, you say why it is safe to run that code that way. It's basically telling the compiler is not smart enough to figure out that it's unsafe on its own, so you have to that it's safe on its own, so you have to tell it, I'm writing what you think is unsafe, but it really is safe, and here's why. And you put a little comment why. John Who. Yeah, John Who. That's his. I think that's his Twitter handle, right? So no, I don't have any unsafe, and the reason I avoid unsafe code is because I don't fully understand safety yet. In order to write code in unsafe blocks, you have to understand why what you're writing is safe. And I still need to learn. All right, so we have an issue here in Locke's instance, line 12. Oops, can't run it, you gotta edit it. 12. Huh. Line 12 is not what I was thinking it was going to be. That's the derive macro. Maybe I'm trying to print something out of the ref cell, borrowed, and it's already borrowed somewhere, and I'm holding on to a borrowed thing. Maybe that's what's going on. Oops, not +1, equals 1. So we're doing an interpreter line 31. There we go. Yeah, so we're borrowing something here, and it's already borrowed. This is what we're doing wrong. Epic Blog says, I have to do something unsafe recently, so now I'm chasing down memory leaks. Oops. Okay. Yeah. So that's why I avoid it, because you have to determine that it is safe in all conditions, and that knowledge is still foreign to me. All right. So this is not the right way to do this. Maybe we have to do it in 2 steps. Let me equals subclone. Maybe RC new subclone, and then we can say an instance of me. I don't know if that'll make a difference to doing it in 2 steps, because the borrow should be dropped here after this line, right? And then we have the clone of it here. So maybe that'll work. Nope. No luck. Oh, it's still on line 31, which means it's, oops. It's this, the clone that's failing. I can't clone. Oh. I can't clone this without panicking. Interesting. I don't really want to anyway, right? What I want to do is be able to create a new function. I don't want to clone the instance in order to create a new function. I want to bind a new function to a ref of me. Right, so I got this function, and I want to create... I need to understand this a little bit better, because I think what's happening is... I mean, the way bind works... What did we do bind? What did we do bind? I've lost bind already. Okay. Sorry for all the extra scrolling that's going on here. So in locks instance in get, if we found the method, then we're going to bind the method we found to a reference to the current instance that we're talking about. And that's in the get expression where we don't have access to the reference for the current. All right. Where do we call the instance get? So we're going to call instance get here, which contains, this inst is an actual RC, so I can just pass in inst to this get expression, and that's an RC. I should call it this, right? And this is an RC to a locks instance. And I can just clone it there, right? RC clone this, and that way I'm using this. I probably shouldn't use this because that might be a keyword that Rust might want to use in the future. Expected reference. Oh, I might have to clone that. Nope, that worked. Okay, so now let's see if that blows up. Oh, haha, it works. Okay, so we had to kind of cheat because we needed to pass in a reference to this because Java does that automatically, but Rust does not. Right, the self parameter in the get is not a reference. It's not an RC reference. It's a reference. And I needed to clone the RC reference. So we can see here it says the German chocolate cake is delicious. So this expression worked. We also had a few other grep this star locks. A few other things that had a this in it, right? So person and pathological and thing. Cat thing. Cargo run thing. Oh, thing got locks. Instance of class thing with the get callback. Yep, so that worked. The other one is person. Cargo run person. And we could see whether it prints out Jane or not, right? Because we're going to call the method. The method is going to call say name. It's going to print this name, and hopefully it's been bound to Jane. And it was. And what's the last one? Pathological. And pathological is where we create a Jane person and a Bill person. We set Bill's say name to Jane's say name. So now that should have been overwritten with Jane's say name. So it should have bound the this for Jane into Bill. So it should still say Jane, right? And it does. Okay, I think we have this working. Supercuber, good to see you. I still have your repo up here that I will be looking at as soon as we're done with this chapter and the next one. Promise. All right, so this is working. It's a little awkward. Yeah, we're up to the this thing, and we're almost done with it. We're almost done with this. It was taking an hour and a half. This took longer than I thought. Get it? This took longer than I thought. Okay, never mind. Moving on. So what do we have? We have all of this stuff for the resolver. I don't care about yeah, so we do the resolution here in the statement. Just going back, here's where we bind the current instance, and I had to cheat with this. And here's the actual bind where we define it. Yep. Okay. So I think we're all good. Is that a Simpsons Santa there? Oh yeah. Looks like the Homer going backwards into the bushes GIF, except a Santa. Okay. Git status, git add, and source commit. Section 12.6.0 this expressions. I put 0.6.0 because now we're going to look at this invalid use of this, which is 12.6.1. Go ahead and give it a try using that cake example. We did. Less than 20 lines of code. Ha ha! The interpreter handles this inside methods, even in all the weird ways it can interact with nested classes, functions inside methods, handles methods, etc. All right. So what are invalid uses of this? What if I say cargo run, print this? Undefined variable this. That works, right? I think that's a valid error. Function not a method, print this. From not a method, print this. Not a method. Undefined variable this. That works. There's no instance for this to point to if you're not in a method. We could give it some default value like nil or make it a runtime error, but the user has clearly made a mistake. The sooner they find and fix that mistake, the happier they'll be. A resolution pass is a fine place to detect the error statically. Oh yeah, okay, so that would have meant that this wouldn't even have compiled this function. It wouldn't have waited until runtime and got it at compile time, right? It already detects return statements outside of functions. We'll do something similar for this. In the vein of our existing function type enum, we'll define a new class type one. So in our resolver, we already have function and method, function type, and we'll have to derive partial q enum class type. It's going to be none or class. And then current class is going to be class type none. So we're going to have current function, current class. So class type. All right, and then we're going to have to define it here. Current class. Yep. So new class type. No. All right. Yes, it could be Boolean. When we get to inheritance, it'll get a third value, hence the enum right now. We'll also add a corresponding field current class. Yep. Epic Blog says summary, address sanitizer. 4160 bytes leaked in 130 allocations. 130 memory leaks. That's not bad. I bet you can get that down to 125 if you tried. Is there a way to do the same code without using unsafe, but just a lot harder, or is unsafe the only option you have? Its value tells us we're currently inside a class. While traversing, it starts out as none. Okay, when we begin to resolve a class declaration, we change that. So in our resolver visit class statement, and it looks like we're doing this before we do declare. So we'll say let in closing class. We'll just use the same style we used last time. Self current class replace class type class. And then at the end, we restore it to what it was, and that's right after end scope. So we just say self current class place, and closing class. And we're done. When we resolve this expression, the current class field gives us the bit of data we need. All right, so this is the push, and this is the pop, right? We're piggybacking on the JVM. We're piggybacking on our compiled code, right? And then visit this expert we just checked to see. Before we resolve local, we say if we're not in a class, then don't do it. Epic Blark says, no, I need unsafe for this. That's a shame. I'm taking it as a learning experience, just wasn't ready for 100+ leaks. Yeah, well, it might be, you know, the longer it runs, the more it leaks, which means maybe you can, if you run it really short amount of time, I don't know what the program is, obviously, but maybe if you just run it for a few seconds, maybe you only get 1 or 2 leaks, and then it might be easier to track them down if there's only a couple. So we say if self dot current class dot borrow. I think I have to say dref. I don't remember now. I'll try it without the dref. Is equal to class type none. It's going to return. It's going to return. So report the error and then return. So we're going to say self error. I think I have a self error. So we just report the error this way. We can give it the token, which is going to be this, expert keyword. And the error message is can't use this outside of a class, which is a little nicer than just undefined variable, right? And then return, okay. And then the resolver reports the error, and then we fail to, we have to do something here. We have to deref it, or put a star in front of it. Oh, I did derive partially. I'll just put a star in front of it. Yeah, okay, so now if we run this, cargo run, if we grab this thing here, print this, can't use this outside of a class, it doesn't even try, and this won't even compile, so there is no not a method in our environment anymore, which is good. Good. That should help users use this correctly and saves us from having to handle misuse at runtime in the interpreter. Very good. Although, the interpreter was handling it correctly, right? Just saying it's undefined variable. But maybe that implies that it could be a variable if you want it to be a variable, which would be bad, right? You wouldn't want to have that on foo var this equals 1, print this. Ooh, that's a weird error. Expect variable name. Oh, because I was expecting it to be a I was expecting this to be a variable, but an identifier, but it's not. It's a this. That's interesting. That would be another error to handle somewhere in this section here, that you could have extended this section a little bit. All right. Git status. I'm going to ignore it. Git add source, git commit, section 12.6.1. I don't know why he made entire this thing was just point 0. Okay, so handle invalid use of this. All right, so 12.6.2. I don't know how far I'm going to get because I only have a half hour left. But we're on constructors and initializers. We can do almost everything with classes now. As we near the end of the chapter, we find ourselves strangely focused on a beginning. Methods and fields let us encapsulate state and behavior together so that an object always stays in a valid configuration. But how do we ensure a brand new object starts in a good state? For that, we need constructors. I find them one of the trickiest parts of a language to design, and if you peer closely at most other languages, you'll see cracks around object construction where the seams of the design don't quite fit together perfectly. Maybe there's something intrinsically messy about the moment of birth. Constructing an object is actually a pair of operations. Runtime allocates the memory required for a fresh instance. In most languages, operation is at a fundamental level beneath what user code is able to access. Then a user-provided chunk of code is called, which initializes the unformed object. Let's see a few examples. In Java, even though final fields must be initialized, it's still possible to read one before it has been initialized. Exceptions, a huge complex feature, were added to C++ mainly as a way to omit errors from constructors. C++'s placement new is a rare example where the bowels of allocation are laid bare for the programmer to prod. I'm not familiar with placement new, but I don't really play around with C++ anymore. The latter is what we tend to think of when we hear constructor, but the language itself has usually done some groundwork for us before we get to that point. In fact, a LOX interpreter already has it covered when it creates a new LOX instance object. We'll do the remaining part, user-defined initialization now. Languages have a variety of notations for a chunk of code that sets up a new object for a class. C++, Java, and C# use a method whose name matches the class name. Ruby and Python call it init. The latter is nice and short, so we'll do that. In LOX classes, implementation of LOX callable will add a few more lines. Okay, so we're just going to call find method init and see if one exists, and then call it. Okay, that makes sense. Right, except we have it in instantiate here. So I'm going to say let instance equals this, and then we're going to say let initializer equals self find method init. Yeah, it just takes a stir. Okay, that's good. I don't have to do anything fancy. And then oh, it's an option, so we can say if let sum initializer. Then we're just going to call it initializer bind instance. Ooh. Okie dokie then. Yeah. And we run into another problem. That didn't take long for us to get stuck. Not in LOX instance. What is it? Where's bind? It's in, yeah, isn't it? Oh, it's in function. Duh. It takes an instance. I guess we're just passing in a reference to it, so it should be okay. Maybe? And then we're saying just call the interpreter arguments like that. Is that even going to work? Because now we have this instance and we have to return an OK of it. I'm nervous. No, we have an error. Method not found on object to object. Oh, right. Some object. Func initializer. And bind returns an object which needs to be a LOX callable function as well, right? What did we do in our right? So bind returns an object which contains a func, which contains an RC, which contains the function to call. So do we have to do this in two steps? If let like that, and then say init.call. Like that. Ooh, compiled. What's the complaint here? Oh, it has a result that must be, okay, so we can just do that because we return the result or an object. Okay, that's not bad. Oops, wrong one. Okay, we're here. We're still going. So it does it, but I don't know if it's doing it the right way. Let's find out. Well, when a class is called after the locked instance is created, we look for an init method. If we find one, we immediately bind and invoke it just like a normal method call. The argument list is forwarded along. The argument list means we also need to tweak how a class declares its arity. So how does a class declare its arity? Right now we're just returning 0, but we need to return the number of arguments that is in the init function. So we have to actually find the method init, just like we did up here. And return the initializer. Sorry, the number of arguments in the initializer. So we can just say initializer dot arity, otherwise 0. Yeah, that works. If there's an initializer, that method's arity determines how many arguments you must pass when you call the class itself. We don't require a class to define an initializer, though, as a convenience. If you don't have initializer, the arity is still 0, and that's basically it. Since we bind the init method before we call it, it has access to this inside its body. That, along with the arguments passed to the class, are all you need to be able to set up a new instance however you desire. All right. So let's see if it works, or if it will panics with a init foo, with a class nested 2D or a function nested 2D pair. Cargo run init foo. We printed out instance twice, once for this and once for this call here, and then we printed the result of the init, which is nil. Can you reinitialize an object directly by calling its init method? If you do, what does it return? A reasonable answer would be nil, since it's what it appears the body returns. However, and I generally dislike compromising to satisfy the implementation, it will make CLOX's implementation of constructors much easier if we say that init method always returns this, even when directly called. In order to keep JLOX compatible with that, we need a little special case code in LOX function. Maybe dislike is too strong a claim. It's reasonable to have the constraints and resources of your implementation affect the design of your language. Yeah, that's true, right? I mean, there are only so many hours in the day, right? That's what I was just thinking. And if a cut corner here or there gets you more features, lets you get more features to users in less time, it may be very well be a net win for their happiness and productivity. The trick is figuring out which corners to cut that won't cause your users and future self to curse your short-sightedness. Yeah. So trade-offs everywhere, right? Is initializer. This is in LOX function. So we're going to add this to LOX function. This is initializer thing, and that's a private Boolean. That's really nice. And if it is initializer, then we're going to call closure.get at 0, this. And this is in the function call. And that's down at the end. If it doesn't match, ooh, I guess it's here. We can say if itself is initializer. This is saying closure get at, and I don't remember what the code looks like to see closure. We have self closure. Maybe that's what we use. Self closure get at 0 this else that, right? And then we're going to have to wrap this in an OK. What does get at return? Actually, let's take a quick look at that. That's an environment. It returns a result of a locks object, of an object and a locks result. So yeah, we can just call it directly like that. We don't need to wrap anything. Okay. I think that's what they're going for here. And then we have to be able to set it somewhere. So in our constructor, we have to say whether or not it is like that, right? And then we're going to have to change. If the function is an initializer, we override the actual return value and forcibly return this. That's what this is doing here. This relies on a new isInitializer field, which we add here. We can't simply see if the name on a locks function is init because the user could have defined a function with that name. In that case, there is no this to return. A function outside the class. To avoid that weird edge case, we'll directly store whether the locks function represents an initializer method. That means we need to go back and fix the few places where we create locks functions. Okay, so that's going to be in interpreter. In visit function statement, we're going to have to pass in a false here. For actual function declarations, isInitializer is always false. For method, we check the name. So methods, it's true that we check the name. Visit class statement. We can just say, I guess, somewhere. Where do we have the method name? Here. Oh no, in the methods. Method.name.lexeme equals init. And what are we passing in here? Let me check real quick. Function. It's a function statement, right? So we have the name there. So we can say let isInit equals func.name as string equals init. And then we can pass that in. Come on. Is init. And then in bind, where we create the closure that binds this to a method, we pass along the original method's value. Oh yeah, is initializer. So is initializer. Okay, let's see what I broke. Get at. The method name get at for. Oh, right, because the closure is a wacky thing. We have to dig into the closure, right? Closure is an RC ref cell, so we have to borrow. Okay. So returning from init. We aren't out of the woods yet. Oh, wait, so maybe this will work now. Maybe when we print foo init, it'll print to this. Let's find out. Cargo run init foo. Yes, so now instead of printing out nil, it prints out instance. So we are now returning this. Perfect. So get status, get add source, get commit, -m 12.7.1, invoking init directly. Okay, so we aren't out of the woods yet. We've been assuming that a user-written initializer doesn't explicitly return a value because most constructors don't. What would happen if the user tries? It's definitely not going to do what they want. So we might as well make a static error. Oh, because we're doing a return of something from the initializer, and that doesn't make any sense. Okay, it makes sense that it doesn't make sense. Back in the resolver, we add another use case to function type. Okay, so we have function. For some reason it puts it in the middle, that's fine. Maybe it's just alphabetical. Initializer. We use the visited method's name to determine if we're resolving an initializer or not. So this is in visit class statement. So just like we did with in the interpreter, we have to peek into here. And we'll take a look here. Oh, I see. We're setting let declaration as function type method. Do we actually need this declaration thing outside? Oops, don't want to do that. Outside, is that just, yeah, it's just in here. So we can just set it directly like this. Okay. So we're going to pull it in. We're going to say this. We're going to say if method name dot as string equals init, then it's going to be an initializer. Otherwise, it's going to be a method, just like that. All right, so that's what we're going to do it that way. When we later traverse into a return statement, we check that field. We check that field and make it an error to return a value from inside it in a method. Okay. So visit return statements right down here. So we can't return from top level code. The statement value is not null. We can say if current function borrow function type initializer, then we're going to report an error. Self error statement keyword can't return a value from an initializer. Okay, and we keep going. We're still not done. We statically disallow returning a value from an initializer, but you can still use an empty early return. That is actually kind of useful sometimes, so we don't want to disallow it entirely. Instead, it should return this instead of nil. That's an easy fix over in lock's function. Didn't we do this already? Oh, maybe this is in a different location. Okay, function. Here's call. Oh, this is the return value. I see. So here we say if self is initializer. Return closure get at this. So it's going to be that. Else. Right? And then locks formatted for me. Nope. Comma doesn't go there. Here we go. That works. Except it doesn't work. Why not? Because I don't know how to spell initializer. There we go. If we're in an initializer and execute a return statement, instead of returning the value, we again return this. Phew, that was a whole list of tasks, but a reward is that our little interpreter has grown an entire programming paradigm. Classes, methods, fields, this, and constructors. Our baby language is looking awfully grown up. We never tested the initializers though, did we? We only printed out stuff, but what if we create our own little init val? I don't know, class foo init a self, oh this dot field is equal to a. And then we can just say var f equals foo of me, print f dot field. Right? That should work. Me. There it is. There I am. Okay. And all it did was initialize the field to a. Whatever was passed in. It could be a string, a number, a nil, a boolean, right? Those are all valid for logs. Oh, Java Z. How do you do hello world in PHP? This is not the right stream for that kind of question, I'm afraid. We have methods on instances, but there's no way to define static methods that can be called directly on the class object itself. And support for that. Really? Use a class keyword preceding the method to indicate a static method that hangs off the class. You know, we could just add a static keyword. There's nothing stopping us from doing that. Rather than saying class. Because then it looks like you're defining a class again. You can solve this however you like, but the meta classes used by Smalltalk on Ruby are a particularly elegant approach. Hint, makes locks class extend locks instance and go from there. Okay, well that's something we can't do in Rust, but whatevs. Most modern languages support getters and setters, members on a class that look like field reads and writes, but that actually execute user-defined code. Extend locks to support getter methods. These are declared without a parameter list. Okay, so it's an identifier followed by an open brace, and then it runs code. Oh, is this Smalltalk like Epic? Epic says getting into Smalltalk. The body of the getter is executed when a property with that name is accessed. Okay. Yeah, I mean, how is it different to just saying print circle.area with open paren, close paren, and then just, I'm not sure what the benefit is there other than it's syntactically shorter. All right. Maybe I'm just being an old curmudgeon. Python and JavaScript allow you to freely access an object's fields from outside its own methods. Right, Ruby and Smalltalk encapsulate instance state. Only methods on the class can access the raw fields. It's up to the class to decide which state is exposed. Most statically typed languages offer modifiers like private and public. What are the trade-offs? Oh, okay. Side note, prototypes and power. Okay, I'm not going to read this on stream. I will read it off stream. And then tomorrow, all right, let's check in with Clippy, make sure I haven't done anything egregiously wrong here. I have. Let's clean all these up, except for this one. I got to figure this out. That's something, maybe we'll do that tomorrow before we start inheritance. Okay, so let's start. So locks function. Oh, I forgot what line it was on now. 23. I can just do that, which means I should be able to just do this. Yeah. Epic says Smalltalk's premise is that nothing is object-oriented enough and tries to solve that. I've seen some OO Puritans say Smalltalk is the only real OO language. Okay. Language wars are fun. So we can remove the return from this line here on locks instance. Can I? Oh yeah, I can, because this is, okay, yeah, good. And then what's the next one? We don't need a toString on self-class on line 59. Okay. Hold on. There we go. Okay, good. And then object has a bunch of toStrings that can go away. Is that it? Then all these toStrings can disappear, which means we can just say func and C and I. Like that. Yeah, look at that. And the only thing should be now the native functions. Okay, so which I'm going to think about how to solve that one, and then maybe we can solve that one tomorrow. Git status, git add source, git commit, -m section. Oh, I forgot the section number this was. Oh, returning from init. 12.7.2, returning this from init. Catching errors, user errors. There we go. All right, let's push that up. Let's take a look. Oh, that's the wrong one. There it is. All right, very nice, very nice. All right, we had a good stream. At least I had a good stream. I hope you enjoyed my stream. I had a good time doing this. And tomorrow we will be looking at, first I'm going to, if I can solve the native function thing, I will solve that. And then we will dive right into inheritance, chapter 13, which I think is the last chapter of this book. Of the Java version, Java section of this book. Yes. And then after that, we're going to dive into the bytecode virtual machine. So we have 2 more days this week. So maybe this week we can actually finish section 2, the tree walk interpreter, before I go back to my roguelike. There we go. So inheritance tomorrow and native functions tomorrow. All right, thanks everyone. Thanks again, and I will see you tomorrow. Take care.